All right, so I'm just gonna walk you through how you can do inverse distance weighting. So I've got the BC air monitoring stations data here. So this is the CSV file, the location of all the air monitoring stations, and then the air monitoring station data. I'm looking at PM 2.5. I'm not going to walk you through the process of importing the XY data or displaying it, because we've already done that. I'm not going to walk you through the join. One thing I will mention, when you do import your data, the tabular data, the locations of the air monitoring stations are in latitude and longitude. You need to make sure that you reproject that data before you do this, because otherwise you're going to end up with a weird result. And so in order to do inverse distance weighting, it's quite simple. Just type in IDW, pick the first one that comes up. And so I've got the point data here displaying the 2019 PM 2.5 data. We can see there's a lot more stations in the lower mainland, but they're spread across the province. And I've got it categorized in 5 different values, but you can see it's pretty hard to interpret this way. And we want to interpolate or estimate what the values are between the air monitoring stations. So you can set the input point features, set your Z value, that's whatever you want to interpolate. In this case, field 12 is the 2019 data. Set the output raster. The output cell size, 4276, is just auto-generated based on the spacing between all these points. That's going to be 4,276 meters. You can keep the default, play around with it, edit it as you want, depending on the resolution you need. And so the way inverse distance weighting works is it's going to interpolate or estimate the values at all points in between all of these stations. And the power is just the degree to which the distance from any given point is weighted, essentially. And so it's normally set to 2. That's the squared distance. And you can just leave it at default. I encourage you to just read the documentation. Just Google ArcPro IDW and read the documentation if you're going to work with this tool to understand a little bit more about what it does. And then the number of points is just how many points nearby should it use to estimate a value. So if you're looking here, estimating the cell value here, it's going to find the 12 nearest points, and so it's going to search for ones that are fairly far away. Whereas if you're in the lower mainland, the 12 nearest points are all much closer. So a point here estimating is not going to be in any way influenced by any of the ones that are farther away. And so we can just run it. And here is the resulting estimate. So this is just interpolating or estimating the air quality in between all the observation points. So we can see that on average, there's something pretty wonky going on up north. I don't know if there was a forest fire season that was quite severe that year, or if the paper mills in Prince George are doing something funky. But we can see that the air quality up there is not particularly good, at least on average throughout the year. So that's just an example. Again, this is just using the yearly average data, but I have this data aggregated in different ways. You can also look at individual months if you want. So this is just to highlight how you can use inverse distance weighting. There's also lots of other applications you could use this for. Say you've got weather stations that have the average temperature or precipitation at a variety of locations, and you want to estimate a surface or approximate the temperature or precipitation between those observations. You would use inverse distance weighting to get an approximation for that as well.